So we talked about discharging capacitor and how Q goes down with time. But let's also talk about current. What happens to current? So in this system, when it is discharging, let's say you had a lamp here, okay? And you start with plus Q0 minus Q0, and this is not only resistance but also a lamp. What are you expecting from the lamp to do while it is discharging? The capacitor is discharging. How bright, what can you tell about the brightness of this lamp? Yes, and then? So, at t equals to 0, it starts. So, you have maximum charge. Is it the brightest at the beginning and then it dims and then the capacitor is over? Do you think that is the case?
Yes.
Yes, I think so too. So, the current here, so Q is CE e to the minus T over RC, right? What is I? I is minus dq over dt. Why I is minus dq over dt? Because it's discharging. Discharging. So, depending on how fast it is discharging, we will have the faster it goes to negative, actually no, the faster it diminishes, the more current I have. That's why it's minus dq over dt. Are you following this? Yes or no? So Q goes like this, and the slope there, this slope is a negative slope already. But if we want to define a positive current, then negative negative makes positive. Indeed, if you calculate it, I is negative 1 over RC times CE e to the minus T over RC. Do you see the derivative here? Did I take the derivative correctly? You see, this is e to the alpha t, and alpha is negative 1 over RC, and I bring that alpha here. Let me just write this here. E to the alpha t derivative is alpha times e to the alpha t. In this particular case, my alpha is negative 1 over RC, and it comes in front. Do you understand this? Hopefully you do. So I is E over R, e to the minus T over RC. Indeed, as you expected, at the beginning, I will be maximum. Yes, tell me.
There is a formula for I in the previous case when
yes.
the capacitor was charging.
Yes.
I don't remember.
Yes, let's also look at that. Let me just make it a smooth curve so that. Okay, I give up. Okay. Do you have any questions? Who proposed the lamp thing? Yes. Are you happy? Yes, I'm using Are you happy? Good. Tell me.
Something. When the capacitor is discharging, the minus charges go to the positive side, right? So the flow of electrons is in the direction from the negative plate to the positive plate. So shouldn't I be in the opposite direction of the
I didn't Yes, you are right. I just drew this without paying attention. Sorry. I is in this direction. That's right. Good. As you mentioned, there is also a formula for the charging case. Let's also find the formula for the current in the charging case. So current in this case is I equals to dq over dt. This is charging. Remember charging? It was charging. So that's why it's plus dq over dt. Okay? For charging case. So I is dq over dt, and we can take the dq over dt from here. So I have C times E, and then I have negative, negative again. So I have minus CE, but it becomes plus CE, 1 over RC, e to the minus t over RC. Turns out that for charging and for discharging, the formula for current is the same. In both cases, so let's say you have a lamp, you have a capacitor, and you have a EMF source. You connect it to charge. At first, the current is high, then it dims out, right? Then you take away the battery and you discharge it. At first, the lamp is bright, and then it dims out. So whether you are charging or discharging, the first few minutes, seconds, depending on your device, current is more than the rest of the time. That's why when you plug in your phone, it quickly goes up to 50%, let's say, but then it takes more time for it to reach full amount, right? Also, discharging quickly drops from 100 to 50%, but it takes more time to go for it to go from 50 to 0. Well, in modern devices, it's much more complicated, of course. They are managing your charging, etc., blah, blah, blah. They are actually making sure, probably they are not saying that your battery level, is the battery level defined as actual charge in the battery or the time you have left? Time you, probably, huh?
It's like linear.
With time. It's linear with time. So it has been calibrated according to the amount of time. So you can fix it with a software. So what you write there at like 30%, 40% could correspond to time or could correspond to actual charge. But actual charge is a bit geeky subject, so probably time, yes.
I mean, let's say that I check how many more hours can I use my phone for,
Mm-hmm.
And it says, let's say, 2 hours.
Mm-hmm.
And then my battery drains out in 20 minutes.
Yes. I would name a brand that would solve it, but I'm putting it up on YouTube. So, all right. Let's continue. All right. Are you ready for it to get a bit trickier than it was? Yes? It's not just one R and one C connected in series, but something that we can actually ask in the exam. Okay, here it goes. Example. So I have this system, R1, C, all right. The question is, At the beginning, there is no charge here. There is no charge here. And at t equals to 0, I started like this with no charge here. Q, t equals to 0 is 0. So my question is, what is I1? What is I? What is I2? What is Q of t? Do you understand the question? We want to find all this. Okay? So here we will have a combination of Kirchhoff's law with what we have seen for charging and discharging, etc. All right. Let's write down the equation for this part. Let me go in this direction. So I have E, right, minus I1 R1, and then what do I have here? I have plus, minus, so minus Q over C equals to 0. Do you agree? Yes? I also have on the other loop, let me look at this loop. I start from here. So I have Q over C minus I2 R2 equals to 0. Right? What else? Right now, I don't have enough equations because I have 1, 2, 3 variables and 2 equations. I need another equation, right? So I can write Kirchhoff's law for here, Kirchhoff's first rule, and it will be I1 equals I plus I2. But that creates a problem because it introduces a new variable, right? So how many variables do I have here? 4, right? Because I1, I2, I, and Q. But I have 3 equations. I need one more equation, and hopefully that one more equation would not bring yet another variable, right? So what is that equation? Can anyone guess?
Perhaps E equals I1 R1 plus I2 R2.
And that would be linearly dependent.
We can use that both is equal in parallel.
That would bring you just same amount of information. What you will get is summation of these 2 equations.
Can we create a third Kirchhoff loop for the whole system?
Yes, this one will bring you just the summation of these equations. It will not be linearly independent. Any other suggestions? How can you make it a differential equation?
We take derivatives, integrals.
You remember why it turned into a differential equation before? We had this dq over dt term. Where is that term here? I, exactly. So I is dq over dt. Now we have 4 equations, 4 unknowns. Are you happy? So our aim is to bring these equations together and hopefully write down just one equation, and that's all. So for this one, I can write down I2 equals Q over R2C, right? So I will write down the first equation again, but I will make sure that I'm writing only the Q terms. So I have E, let me get it step by step, okay? E minus I plus Q over R2C. Actually, let me do one more step here. dq over dt. Do you see what happened? I1 was I plus I2. and I is dq over dt, so I wrote dq over dt, and I2 is q over R2c, so I wrote q over R2c. Did you follow this? Yes? Anyone who didn't follow this? Everybody follows. Minus q over c equals 0. Do you see I already have my equation? Just one equation with a single unknown q. It's a first order differential equation, and I will use the same trick. By the same trick, I mean I will leave q alone, and I will collect q's on one side, t's on one side, and solve this. So let me rewrite it. E minus dq over dt R1 minus q over c times R1 over R2 plus 1. Do you agree with this? I collected q's together, dq over dt's together. If you have any questions, just let me know. So what I want is, eventually, what I want is dq over dt times something equals q minus something. I want to turn it into that, right? That's what I did before. Do you remember? Yes? So to achieve that, I will multiply this side by R2c over R1 plus R2. Okay, let me just multiply it with that. What do I get? I get CE R2 over R1 plus R2 minus dq over dt. I have lost you completely, right? Did I lose you completely? So, I have dq tell me about it. Just check my algebra, okay? CE R2 over R1 plus R2. So I will bring down the right hand side. It will be Q minus CE R2 over R1 plus R2 equals to minus dt R1 plus R2 over R1 times R2 times C. Okay? And I will integrate from 0 to t, making this t prime, integrate from 0 to q, making this q prime. And what do I get? Full points from one question in midterm 2. Right? This is it. 1 minus R1 plus R2 times t over R1, R2. Okay, I forgot the exponential. Yes. This is it. This is the result. Tell me. Which part? This part, okay. Do you have any questions?
No, why are you making Q and T prime? If you don't make the same thing happen.
You can't have your variable and your limits of integration the same thing. It has to be different things, right? So we are just renaming it. Okay. Why I did this part, right? Why I did this part. If I don't do that part, I will have some coefficients in front of Q. So when I arrive at this point, there will be a coefficient in front of Q. So it will not be ln Q minus something, but it will be that coefficient times ln something. So I'm just getting rid of that coefficient at the beginning. Any other questions? Sure.
Can you write down somewhere what are the values?
What values?
No, no. Can you just write down somewhere that I will tell you? I will tell you an equation.
Okay.
I just want to say that it's correct or
Okay.
you need to go scroll up, please. Okay. So basically, we have on the current we have two resistance and one capacitor. So E minus, let's say E minus
Mm-hmm.
I1 minus Q over C and minus
No,
I2 R2
that's it. You cannot
equals to 0.
you cannot jump to a new loop.
Yeah.
Okay, that's not allowed.
That's the reason why we don't.
Yes. So what you do is you take this loop and you write it down here. You take this loop, you write it down here, and then you combine things.
Because
Okay.
I was trying to find the combined equation for all the elements of the
Yeah.
That's it.
Well, there are some tricks in analysis of electrical circuits, but we don't teach them. If you are wondering what those tricks are, they are called Thevenin and Norton rules. Like there is this guy called Thevenin and another guy called Norton. They have some rules that simplify electrical circuits, but we don't teach them. I will come to your question. And what else? Yes, because you see, we did all this algebra, and it turns out that although the resistances don't look parallel at all to you, maybe, right? Don't look parallel, but they act as if they are parallel. Because look, what is tau? Tau is C times R1 times R2 over R1 plus R2. And what is that? R equivalent, when R1 and R2 are parallel. Are you getting it? So this is C times R equivalent for parallel case. It means that somehow this circuit, by this I mean parallel, okay? Somehow the circuit acts as if R1 and R2 are parallel, but you can see why that happens only if you know those tricks. So be on the safe side, use Kirchhoff's rules.
Can we solve a question that contains
Multiple capacitors, yes. Sure. They are usually easier, but this is a good question. So let's solve one. So where do you want to put your capacitors? Maybe like this? Yes? So let's try solving this problem. Let me call this I1, this one I, and this one I2. Okay? So I have E minus Q1 over C1, right? Minus I times R equals 0. So far so good? And on the other one, I have I times R equals Q2 over C, or let me write it like Q2 over C minus I times R equals 0. Same thing, but just written proper way. Then I have I1 equals dq1 over dt, and I2 equals dq2 over dt. So far so good? And I also have I1 equals I plus I2. Right? Then we can figure this out, hopefully. So we need to choose a protagonist here. Which one is the main actor?
Perhaps I1. Because,
You mean Q1?
yes.
I mean, we need to write it in the Q level. So should it be Q1 or Q2? Q1. Okay?
Because if the first capacitor is charged, then no more, current would be able to pass, right?
We will see. We will see. We will see. So Q1 over C1 minus I1 plus I2 R equals 0, right? What is I1? R times dq1 over dt.
Hocam, I is not equal to I1 plus I2. I1 minus I2.
Is it?
It is. Sure.
I1 is equal to I plus I2.
No. I is equal to I1 minus I2.
Tamam, aynı şey.
Nasıl aynı şey? Equation'da I'ın yerine
Ah,
I1
okay.
plus I2 koyuyorum.
Thank you. So are we happy so far? How can I get rid of dq2 and make it just about q1? Can I actually do that?
Perhaps the second equation could help. Perhaps the second equation could help.
Does it help though?
I don't know. I would need to see.
It could be the case that you get coupled first order differential equations. That could be the reason why we never ask this kind of questions. Should we keep on thinking about it, or let's come back to this problem? Very good, very nice problem. So I will come back to this problem. Okay? Any questions?
Can be in midterm too?
What?
Can it be in midterm too, like in this?
No. Should it be?
No.
It is not.
Why not?
Like they don't teach how to solve this kind of mathematical equations. in
Yes, but
101 and 102.
Yes, maybe.
There are tricks, perhaps you could ask, but if there are no tricks,
Okay. Okay. So I think I'm done with this chapter 2. So we have 10 minutes before the quiz. In those 10 minutes, we can solve an example question. Okay? So we go all the way back. This is summary and recap of chapters 21 through 24. Actually, I should call it just problem solution. So let me start with a typical question that probably you have studied, so you know how to solve it, but for those who haven't studied this part, it could be interesting. So let's say this is plus Q, this is minus Q. The question is, what is the electric field at the center? This is a wire. You have plus Q in the second quadrant, minus Q in the third quadrant, and you are asking for the electric field. You have solved it already, right? So what are you planning to do in this 10 minutes? Is it helpful to you to see it again? Yes. So maybe you can help me solve it. How can we solve this?
I first had to write directions because
Mm-hmm.
since they have a symmetry and their charges equal just the opposite signs, there are some directions that cancel each other.
Okay. So what are they? So for example, if I have theta here and another one over here at negative theta, let's say.
Yes.
So this one will create electric field in this direction,
Yes.
and that one creates electric field in this direction, right? So EXs cancel each other out. Do you see that? So I will always deal with EYs. I only care about EYs, so I will not even calculate EXs. Are you okay with this? Yes? So how do you calculate EY? So let me just, after I made that point, how can I calculate this DEY over here? DE times sine theta. Yes, very good. But with a negative sign, right? DEY is negative DE times sine theta. Actually, let me not bother you with negative signs. We will put the direction at the end, okay? So far, so good? Any questions? No? All right. What is DE? It is this dq over here that is living inside d theta, right? And let me say this is r. So it's k times dq over r squared. Do you agree with this? What is dq?
Lambda times
Lambda times
d theta.
d theta. And what is lambda?
Q. 2Q over pi r.
Okay, so here's the thing. If you are saying that this lambda is charge per unit length, then theta is not enough. You should have also r here, okay? But if you are saying that lambda is something that you have newly defined and it's charge per unit angle, that's also acceptable. So we could have written it like this. Charge per unit angle, so I'm talking only about this one. So plus q divided by pi over 2. Do you see? Plus q divided by pi over 2 times d theta would do it. So because in pi over 2 you have q, then in d theta you have dq. All right? We didn't even use r here to find dq. But if we were to use the lambda, then we would have pi r over 2 here and d theta over here, and r's would cancel anyways. So far so good. Dey is k over r squared times 2q over pi sine theta d theta. Right? And we go from 0 to pi over 2 for the upper one. Right? The lower one will contribute the same amount. So we will just multiply the whole thing with 2 at the end. But for now, it's basically 2kq over pi r squared. Integral of sine is minus cosine theta, evaluated at pi over 2 and 0, and it becomes 1 at 0, right? At pi over 2, it's 0. So I get a positive value from this, right? I get just 2kq over pi r squared. Do you agree with that? All right. So the E total will be twice this much. So it will be 4kq over pi r squared, but it will be pointing in the negative j direction. Do you agree? Everybody agrees? Okay. So I am taking the integral from 0 over here to pi over 2 over here. So I'm taking integral from here to here. It doesn't make sense? Does it? Why not 2 pi, right? Did you get it? Yes, you yes.
Why? I didn't understand pi over 2, q over pi over 2. Because it's the length, pi over 2.
Yes, let's do it with length. So if you do it with length, then it's pi r over 2, right? This is pi r over 2. Then this distance is not r, it's not d theta, it's going to be r d theta.
Why is that?
Let me tell you why. So when you have a circle, what is the circumference?
2 pi r.
Exactly. So r times the whole angle.
It's not whole angle.
Yes. And when you have a certain amount of angle, like d theta, then that length is going to be r d theta. Okay? Quiz time.